Alright, so like I told y'all, I'd start on this backwards for you. Let's see, the instructions up here are to find all the zeros and write the polynomial as a product of linear factors. So I'm going to cheat. Go to my calculator. I'm going to graph it. I'm not going to do all of these. Once we do one of them, that's going to be it. I'll leave you at least one to practice on. Anyways, looking at the graph, there's two zeros here. I'm pretty sure one of them's at 1. That one's probably at a half. I'm going to put a 0 in y2 because it's a 0, kids. And I'm going to use the intersect feature to figure out what that one is. So I'm going to get close, and I'm going to press enter 3 times. And it is, it's a half, just like I thought it was. So I know that x is a half, and I know that probably x is 1, because I'm pretty sure that's at a 1. Do a little synthetic division. Drop and you multiply and you add, but you know all that. And I'll reduce it again. This time I'll do out the half. I'll save the half for last. Remember, this is a remainder, constant, an x and an x squared. So this is 2x squared plus no x plus 19 is 0. You can do that however you want. I'm going to use a quadratic formula. So 0 plus or minus square root of 0 squared minus 4 times 2 times a 19, sitting over twice at 2. And what's the net radical? 8 19s. So 80, 72, negative 152. Negative 152 is probably divisible by 4. And it is. It's a nice division. So it's going to be written as 4 and 38, and it's not real, so I'm going to put an I out front. So plus or minus I roots of 4 38ths all over 4. And I can evaluate the root of this 4. Plus or minus twice I root 38 over 4. And I can just kind of, cancel it out a little bit. So plus or minus I root 38 over 2. Now, that's all the zeros. We would not actually write these out using factors. We don't do that. We're going to only use the real zeros. The linear factors are the 1/2 and the 1. So if 1/2 is 0, x minus 1/2 created it. And if 1 is a 0, x minus 1 created it. And then we have this thing. Again, we only want real things demonstrated as we factor. And this guy is 2x squared plus 19. And that is just an ugly looking thing. It really is. Normally what we would do is we'd pull a 2 out of this and give it to this thing. It's still going to make this guy ugly. I'm still going to do it. Usually you try to clean up these linear factors so they look nice. I'm going to pull the 2 from x squared plus 19, so I'd have x squared plus 19 halves, 9.5 if you like. And I'm going to distribute it in there. That's what they're supposed to look like. Not a big deal though. So I did 34, you guys should be able to do 33. Now I'll jump up to 32. There's a way you're supposed to do 32. You're supposed to do it with synthetic division. If 3i is 0, then negative 3i is also 0. And I think they want you to find all of them with that one being given. Let me go back and look at the instruction set. Yeah, instructions on these are use the given 0 to find the remaining zeros. Now, I'm going to take a look at the graph of this thing. So I graphed it. There's the 1, 0. It only has one real. It has a real 0, probably 2. Yeah, I was looking at the table there. I hit second table. It has a real 0 at 2. And I am aware of 2 imaginary zeros. So I'm going to do a little synthetic division. And I'm going to pull the real one out first because it's easier to pull them out. Twice 1 is a 2. Negative 10, 2 makes negative 8. It's negative 16. It's negative 26. Sorry, positive 26. It's going to be 52. Negative 72. Negative 144. 50. 153. 306. 0. So that one worked out. Now I'll start pulling out the imaginary ones. It doesn't really matter if you pull out the positive one or the negative one first. I'm just going to do the positive 3i. Alright, so 1 times 3i is 3i. When we add down, we have negative 8 plus 3i. And here's where I start going to calculator because I don't want to take all day on this. So 3i times negative 8 plus 3i is a negative 9 minus 24i. Remember, we add down. We add down. So 26 plus a negative 9 should be 17. 17 minus 24i. And I repeat, 3i times 17 minus 24i is 72 plus 51i. When I add down, the real numbers annihilate each other. I'm left with 51i. And 3i times 51i is 153i, which is negative 153. There's your 0. Pull out my negative 3i. And this one's going to be a lot easier than the last one. So minus 3i, the i's cancel, minus 8. When we multiply here, we're going to have a minus positive 24i. The i's cancel, left with 17. We multiply there, we're going to get negative 51i. There's a 0. So we're left with this little quadratic x squared minus 8x plus 17. That thing's not going to factor. There aren't factors 17 that gets you negative 8. So you're just going to do a little quadratic formula. That's going to give you a 64. And what's this going to give you? 40, 28, 68. You are going to have a negative 4 in that radical. And a negative 4 is going to be plus or minus 2i. So we do the division here. 8 over 2 is 4. 2 over 2 is 1. 4 plus or minus I is your last two zeros. And there you go. That was, of all your synthetic division ones, that's probably the hard one. If you can do that one, you can do any of them. And I'm going to jump up to 30. It says form a polynomial. I'll leave 29 for y'all, but 30 says form a polynomial. All right, so the degree is 5. We have a 0 at 2. We have a 0 at negative 3i, which means there's a 0 at 3i. We have a 0 at 4 minus I, which means we have a 0 at 4 plus I. These are the ones that are pain in the butt. This is literally telling you that a 0 is at 2. It's saying x equals 2, which means x minus 2 is 0 because we jump over. So that's where that factoring idea is coming from. We also have a 0 at negative 3i, so we say plus 3i is a factor. And positive 3i, so we say minus 3i is a factor. And put these guys next to each other. Remember, when you enter a set of parentheses, you change signs. This is minus 4 minus I. In fact, I'm just going to kind of do it this way, minus all of it. A lot of your college professors teach this technique. Because instead of doing the triple distributive property, they just want a FOIL, which I understand why they want to do that. I'll leave x minus 2 alone for a while. Now here you got your x squared. You have a plus 3ix minus a 3ix. They annihilate each other. And the outside is a minus 9i squared. That's a plus 9. Now here you're going to do x times x, that's x squared. You're going to multiply these two things together because you're foiling. So you do a negative 4 minus I. Hopefully this is 17 times a negative. Notice it's a negative symbol in the calculator, not minus. 4 plus an I. And it's 17. Now the inside piece, you're thinking about joining. You'd have x times a negative 4 plus I, and then you'd be adding to it another one of these, an x times a negative 4 minus I. I wrote that wrong up here. Anyways, that makes a minus 4x. That makes a minus 4x. You also have a negative times a negative, so plus an ix. Here you have a negative times a positive, so minus ix. And like I've been telling y'all, those pieces cancel. You're just left with this. And you can kind of look at this and just kind of 4x. So negative 8x. All right, now how you proceed from here is up to you. Personally, I'm going to do these because I'd rather FOIL before I do something else. So that's an x cubed plus a 9x minus a 2x squared minus an 18. And then I have x squared minus 8x plus 17. I probably should have rearranged this, but whatever. There's no like terms. So I'm going to x cubed everything. X cubed times x squared is x to the 5th. X cubed times negative 8x minus 8x to the 4th plus 17x cubed. Then I'm going to 9x everything plus 9x cubed minus 72x squared plus 153x. X negative 2x squared everything minus 2x to the 4th plus 16x cubed minus 34x squared. I got negative 18 everything, so minus 18x squareds plus 124, I think. 144. Yeah, 144 x's. And 18 times 17. Plus 300, sorry, minus 306. I'm going to leave simplification of that up to you. I'm not going to spend time on it. From there, it's combined like terms. 28 is like a gimme question. It doesn't say form a polynomial, it just says find the remaining zeros. So you were given 2. The degree is 4. because you need two more. And if I is a 0, negative I is a 0. If 2 plus I is a 0, 2 minus I is a 0. So that's a gimme question. Those are questions you're not supposed to miss. All right, solve this one in the real number system. Well, that means you find real answers. And I'll be honest with you, you're going to graph it. That's what you're going to do. $26, not going to worry about. 25 is a list of potential zeros. Just what are they? This is factors of the end over the factors of the front. The end is 2. The front is a 6. The factors of 2 are plus or minus 1 and plus or minus 2. To get to a 6, and it helps if you write in order, it takes a 1, a 2, a 3, and a 6. Now you just do your division. So your list is going to be 1 over 1, which is 1, 2 over 1, which is 2, 1 over 2, which is a half, 1 over 3, 1 over 6. You'll do 2 over 1, 2 over 2, which you have is 1, 2 over 3 is new, and then 2 over 6 is a third, which is already done. So there's your list. '24 talks about remainder theorem. It's worded kind of funny. Talks about what's the remainder when you divide by x minus c. Well, that's here, dividing by x plus 1. Now, there's two ways of doing this. I do say or synthetic division, but if x plus 1 is possibly a 0, then x is negative 1. That is a possible 0. Remainder theorem says if f of some number c is 0, then c is a factor. Sorry, then c is a 0. It also says if f of c is some number, we'll call it r is the remainder. You literally just have to figure out what f of negative 1 is. Which you do by plugging in a negative 1. That's to the 6th power, that's a 5. That's the 3rd power, that's a negative 1 times a negative 3 is plus 3. And then plus 8, you get 16. Of course, you can also use synthetic division, but you still got to divide by a negative 1. I actually did not mean to put 23 on here, but I did, so I may as well do it. So they gave you an equation. This is actually from Unit 4. I had you guys do this in Unit 4, and I was telling you guys to do stuff by hand. So I'm going to do it by hand. For what intervals of time is the ball less than 192 feet above the ground? So we're going to take the equation for the height and say less than 192. Now anything with a quadratic is one-sided. It should also be put in standard form. That is going to be factorable. I'm going to pull the negative 16 out to make the numbers smaller. And then plus 12. If I just pulled the negative 16 out to make the numbers smaller and easier to work with. Anyways, the factors of 12 that get you to 8 are 6 and 2. And they're both negative to add to negative 8. Now, when I did this with Unit 4 with y'all, I told you to look at the graph. I'm just going to kind of rough ball the graph. This is a ball that is thrown up, and eventually the ball will come down. I'm curious about when it's less than 192 feet above the ground. So here's this idea of 192 feet. I'm less than 192 here and here. Now this would be where the time is stuck between 0 and 2. Because if we solve these things, these are our times, 6 and 2. So this is literally where t equals 2. So anywhere from the 0th second when you first throw it all the way up to 2 seconds. This guy right here is where the time is between 6 seconds and whenever you hit the ground. So I still got to find when I hit the ground. When do I hit the ground? Alright, so off to the side, I hit the ground by saying 0 equals 128t minus 16t squared. I can pull that 16. If I pull a negative 16 from negative 16t squared, I have a t squared, and I should have pulled more than that. And I'd have a minus 8t. I should also pull the t out. Use the cover-up method. That would tell me that time is 0. Of course, that makes sense. It means nothing to the context of this question, but that's the one that does. The ball hits the ground at 8 seconds. So now you can answer the question. From 0 to 2 seconds and 6 to 8. That's 23. We'll do an inequality with you. We'll do this one. Where is this thing less than or equal to 0? And I'll use a graphing calculator on this one for you. But that one factors. Factors of 14 are 7 and 2. So minus 7 plus 2. These are actually called what we call critical values of x. A critical value of x is 7, and a critical value of x is negative 2. Now you talk about being less than or equal to 0. That's where the graph is below the x-axis. What it means, where is it below the x-axis? So anyways, I'm just looking at the graph. The x-axis is below the graph, the x-axis from here to here. From there to there. So between that negative 2 and that 7. So I know that x is trapped in between. You get to use the equality symbols, negative 2 and 7. Of course, the answer choices is in interval form. That's that notation as an interval. All right, moving on to 20. 20 is about vertical asymptotes. Vertical asymptotes, they happen when you divide by 0 after simplifying the function. It basically means factor. So x squared minus 36, so we call that dots pattern. It's x minus 6 times x plus 6. And you can't cancel anything out, so it's reduced, it's simplified. So my vertical asymptotes, again, we're thinking about dividing by 0. We're literally thinking x minus 6 equals 0, x equals 6, or x plus 6 equals 0, x equals negative 6. Anyways, that is choice C. Don't be the kid who picks B. Don't be that kid. The oblique asymptote. Deal on this is the degree of the numerator is 1 degree higher. And what we do is we do long division. So, long division. Now I'm dividing by x cubed plus 6x plus 5, and I'm trying to enter 2x cubed plus 11x squared plus 5x minus 1. I got to multiply this guy by a 2x. 2x times x squared is 2x cubed. So I 2x the whole thing. Distributive property. 2x cubed plus 12x squared plus 10x. And remember, I always tell you to wrap before you subtract. 11 minus 12 is a negative 1. 5 minus 10 is a negative 5. And we're going to bring that guy down. Now the new goal is to turn x squared into negative x squared. You should be thinking negative 1 times x squared is negative x squared. So minus 1. And honestly, that's all you have to do. It's right there. You don't have to do anymore. There will be kids who miss things like 18. Y-intercept happens when x is 0. That's when it happens. You're thinking you have a 0 minus 12 over 0 squared plus 12 zeros minus 14. Most of the kids who miss this are the kids who rely on that calculator. They really, really are. But anyways, that's because they don't understand that these are zeros. That's a negative 12 over negative 14, which is a 6/7. And think about what you did. You said x was 0, right? Well, that's the first ordered pair, x, y. And you see y is 6/7. So there she is. We'll do 17 on domain. And this is written out with set builder notation. It's as easy as it gets. Anyways, the deal is that 3x squared plus 6x minus 72 cannot be 0. It cannot be 0. Notice the not symbols. You factor. I'm going to pull a 3. I just did that to make the factoring easier. I noticed that all 3 pieces were divisible by 3. If you don't see it, you don't have to. It just makes the factoring harder. A 24 is an 8 and a 6. Sorry, a 4 and a 6. You want to be a positive 2, so minus 4 plus 6. Remember, we are not 0. So I know that x is not 4, nor is it negative 6. You stretching? That'd be choice C. Use the graph to find the oblique asymptote function. Another word for oblique is slant. A slanted asymptote. That's this thing right here. And that's literally where you think about mx plus b, kids. If you don't realize that's y equals x, I cannot help you. That thing crosses at the origin. B is 0. Its slope is rise 1, run 1. Y equals x. The graph to find the horizontal asymptote. Well, that would be this dashed guy right there. According to the scale, that's y equals 1. All right, speaking of horizontal asymptotes, there's only 2 rules. Degree of the numerator equals degree of denominator. It's this one right here. We'd have something like, say we had y equals a over x, c over x, plus some crap. Well, this is just a over c. Well, these guys match. We think y equals 9x over x. Y is 9. If you looked at the graph of this function at 9, you would see something that it may cross at the origin, close to the origin, but not past it. The other rule is in 13. 13 says degree of numerator less than denominator is always y equals 0. And we see that. That's because the bottom grows faster than the top. You take something large, divide it by something small, you get something close to 0. This thing gets large quickly. So you take something even larger, divide it by something relatively small, closer to 0. And you just keep approaching that idea forever. Those are the two rules, this one and that one. There is no rule for horizontal asymptotes about the degree higher, numerator higher than denominator. This one, if you know your rules, this one has a slant asymptote. Because x squared is 1 degree higher than x. There is no horizontal asymptote. Those two things don't happen together. All right. I'm not going to do 10. It has one. I guess the last one I'll do with y'all is 8, because not everybody got to 8. So I'm going to go to Stat, Edit, and I'm going to put this information in List 1 and List 2. And this calculator lets me do something a lot of calculators don't do. So I'm going to do it this way. Stat calc, it tells you, it talks about it, a cubic function, so cubic regression. This calculator has a cool little feature there at store. I'm going to store it somewhere. I'm going to hit the vars key. I'm going to arrow over to y, variables, function, y1. And that is actually going to put the results of this into y1. Now, if your calculator doesn't have that, you need to write these out to the 4th decimal place for accuracy. So anyways, there's the function. It's in y1 like it's supposed to be. A zoom 6, probably not going to do me much good, but I should hopefully start seeing some of the graph. Yeah, there is some of the graph. I'm going to look up. I don't know how far. Maybe 100. I haven't actually done this problem. 100 did it. There's the maximum amount of water in the tub. Second trace 4 for max. You get close, you get to the left, you press enter. You get to the right, you press enter. And enter for a guess. 5.294. So that throws out choices B and D. D possibly depending on how you rounded. Now, several kids who did this in class, they didn't know how to figure out when it ran out of water. This is where you run out of water. There is no water in the tub because Y is the water in the tub. So here there's no Y, there's no water in the tub. So I have a 0 on Y2 so that I can use the intersect feature. And all I got to do is get that cursor close to it. And when it's close, I press enter once, twice, thrice. 8.22 seconds. That makes it choice A. And I got to stop. Good luck on your test tomorrow.